All right. This is just in response to number 6 from these projectile questions. It says a player kicks a football with an initial velocity of 15 meters per second at an angle of 42 degrees above the horizontal. A second player standing at a distance of 30 meters from the first in the direction of the kick starts running to catch the ball. How fast does he have to run in order to catch the ball before it hits the ground? So the situation is just on flat ground. I didn't draw that very flat. Let me try that again. And it's just doing this. So it's fired at an angle of 42 degrees at a speed of 15 meters per second. Since it starts on the ground and lands on the ground, then dy is 0 because it lands in the same spot that it started in the y direction. So that makes some things easier, but a little bit tricky to understand, I think. So let's scroll down on this and see what we can do with that. So just like you would before, you find your Vx and your V1y, and they are what they are. You're going to go 15 cosine 42 and 15 sine 42. You're going to set it up in equation 3 again with dy equals V1y times t minus 4.9 t squared, but it's going to be easier because dy is 0. So you're going to put your V1y in here that you find from above, minus 4.9 t squared. You're not going to have to use the quadratic formula this time because it's going to be negative V1yt equals negative 4.9 t squared. The negatives will cancel out. You'll end up with, well, I'll write the negatives in here for another step. It'll be, if I divide both sides by t and both sides by 4.9, then I'm going to get negative 4.9 on this side and just time on that side. These t's will cancel out, and that'll cancel that squared out. And then, like I said, I didn't show what I did there, but I also divided the 4.9 over on the other side. So this will be what you get. You can see the negatives will cancel out. So whatever you have for V1y, that'll be the time. I forget, I did this in class for a group of students, and I feel like it was like 2-point-something seconds. And of course, you find the range dx equals the Vx that you have above times that time that you just found, and that'll tell you how far the ball goes, because that's dx there. Now it says that there's a player. I think it ends up being like 22 meters or something if you do it right. Yeah, I think that's right. So you get 22 meters that the ball goes. Anyway, I can't remember exactly, but it says the player starts 30 meters away from the kick. So the player just has to run the extra 8 meters. Again, that's assuming my guess of 22 is right there. I don't like that auto circle. So the player's just got to run 8 meters to catch the ball, and they have how much time to do it? Well, whatever that same time is. It says they start running the instant that you kick the ball. So the speed they have to go at is just that, let's say, again, about 8 meters. That seems to ring a bell, but please don't, but figure it out yourself and make sure it is 8. And then it's divided by whatever that time is that you had from above. I think it's 2 seconds or something like that, 2-point-something maybe. And that's how fast the runner has to go. Mathematically, not a very hard one to do, but confusing to set it up and to realize that the dy is 0 and all that stuff. If there's any other issues with that one, just let me know and I can point you in the right direction. Again, if you're working on something and you have, if you have a solution, but you're wondering or you're worried that it's wrong, if you send me a picture of it, I can tell you if it looks okay or not okay. Anyway, this is a quick one. I'm going to sign off so it uploads quickly.